What's up, people, and welcome to the third and last video of the PID controller tutorial slash demo. So in this part we're going to go through all the code and how the math is applied to the game that is demonstrated in the second part, the previous video, right? So this video is for the ones that are interested in applying this math pragmatically. So let's see what we have here. We have three things here. We have the display, which is kind of like the screen, how big that should be and where the center point is. The center point is what I call the marker, also the circle. The background is actually not used. You can set that background image if you like, but I think it wasn't as clear when I did the demo, so I removed it. The width and the height of the drone, that is need to be this width and height because that's how big the image is. This image, the drone PNG image. The position is the position of the drone. The pos history is the position history, and I need that for the integral, which is going to be clear later. The memory length is basically how big we allow this vector to become, so it doesn't like explode. And the force is how we apply the force to the position. The PID should be clear from the previous video. The pull force is how much force is applied when we click, basically when we apply external force by clicking, that you saw that I did with the vector illustrated by the red line. Right, so this is some Pygame stuff. I don't think it's important. It's just like initialization and setting the game display to width and height, giving the title, and setting the clock, which we need for ticking later. Some functions, blah, blah, blah. I'm going to scroll to the end here. This is the game loop where the game starts. Basically, you're gonna start here, and then you're gonna iterate here, and then you're gonna call different functions depending on if there occurs any event from the Pygame. So the events that we have here is the quit, which is actually not used, and some user input. This is the important thing. So if on mouse up, basically meaning that I have clicked somewhere. If I click with the left mouse button, which is button 1. I'm going to call the onClick with the position in the screen, X and Y position in the screen where I clicked. If I click on the right button, which is button 3, for some reason, I don't know why. But then I'm going to call the right button click, or on right click it's called, with the X and Y position also. So, and also if I move around the mouse, I'm just going to call this function with the X and Y position of the mouse. Basically just storing the position of the mouse in this applied force function. In the end here, I clear the screen so it becomes white, and then I update the game logic, and then I redraw all the things that should be drawn. And this is Pygame stuff, setting the frame rate and updating and stuff, and then quitting the game, blah blah blah. Doesn't really matter. What's important is this update and draw function. Update, it's updating the game logic, and draw is redrawing the resources for the screen. So let's take a look at this onClick here, see what happens. On click, what I do, I take the position of the X and Y position of the mouse on the screen, stored in this pos, which is like a NumPy. NP is sort of a NumPy array. And the reason why I do this is so that I can use vector arithmetics on it, as I explained in the previous videos. I have the force here calculated by the position minus the position of the mouse minus the drone position, and then I divide it by the drone position, so I get like percentage-wise how far off it was. So I get like a percent of it in a decimal, and then I multiply it with the pull force. Basically, if I set this to a higher number, the pull force when I do a click is going to be greater. Basically, it's going to drag it, really hard or really slow, depending on what I set this value to. So that is what that is doing, and then I just apply it. This force to the drone force that it is already having, basically the acceleration of the object with the plus equals sign here. And this is just printing variables, so I can see it in the terminal here. When I do a right click, I grab the X and Y you know, X and Y position of the mouse, and I store it in the display center. I use this later to draw the circle and having the center point set to this position. And this position is in the game where the drone is going to try to move to. The center point is where it is calculating its error. So that is the clicking thingy. Let's have a look at the drawing thingy. The draw function, I have commented this out. If you want to draw the background, go ahead and do that. Just comment this in. I draw the drone PNG image. Just super simple. I draw it, the position here, the image that I have loaded up. I need to divide it by half, so the center point is in the center of the PNG image as opposed to the top left corner for the X and Y axis. So that is why the division by 2 is there on the width and height. So I draw that, and then I draw the line, the red line, you know, that I'm calling the applied force. That is, you know the one when I run it. I actually should probably show you. So the what I call like the applied force is this like red line here. It is constantly updating, even though it is not clicking on it, but it's storing the position from the mouse and redrawing this line. So that is that. And the circle is the marker that I draw at the display center. Right, so that is the drawing. So now comes the heavy part. Let's check out what is actually interesting here, the update function. This is only updating the PID variables, like it's updating them like this, and this is what is mostly relevant to this video. If there is any history, we add that to the derivative, blah blah blah. Then we apply the forces. And if you check this out, you can see here this component thingy that I talked about, the linear combination. This is where that is happening. But we'll get there. And then we append it to the history and make sure that the queue doesn't get too big. So let's start with the proportional force here. We have a function called getProportionalForce, or getProportionalError it should be. And the center is like how far off is this position to the center. So distance to center is going to be basically, yeah, the center minus the position, right? And then we take this and then we divide that by the display width and height. And we do that so that we will get a percentage of the screen size. So, you know, the drone doesn't move faster just because you have a bigger screen, because that, you know, doesn't make sense, right? So we divide it by the width and height of the screen. So that is how you get the proportional error. So for the P error here, it's super simple. You just call that function. You give it the position where the marker is placed as the center position. That is where it's going to calculate the error to. And then you give it the drone position, which is like where it's going to calculate the error from. So like the distance between these two, basically the proportion there. That is the P variable. The integral value is pretty straightforward. We have this history of previous positions that we store here at the end of the loop, at the end of the update. And what happens here is basically you append the current drone position to this list, and you know, if it is greater than this threshold that we have set, we just like pop the oldest one from the list. So we just have this, I think it's 1000 or something. Yeah, it is 1000 items maximum in this list at all times. The 1000 most recent entries of the positions. So that is what this does for you. So for the integral force, what you do is you iterate through this history of previous positions, and for each one of these, you sum up the error that you have at all these points. And I can't really bother, but like you have to, instead of doing plus equals, you have to do minus equals here to reverse the proportional error for reasons. You can try and go ahead and test what happens if you take plus here instead and see what that does for you. And what you do here instead is you take the entry for the previous positions in the history and to the display and center. So since this is having a history of previous positions, that means that when you relocate this like circle thingy, you have to clear out the history. And that is what's happening here. You have to reset the history if you place a new marker, because now, you know, this data is old. It's not relevant anymore. So the integral part is like the history of proportionals errors in a way. Now the derivative is a bit different. This is kind of interesting. You have to do some sanity checks to see if there is actually any previous entries, otherwise you can't use it. But you also use the proportional error here, and then you use the previous error and the previous error. So like the two most previous errors, two most recent errors. And what you do basically is you calculate how much difference there is in the error. So maybe my error was reduced a little bit by moving very fast. And that is what you store in this derivative force for each dimension, like the x and y. So take a moment to reflect on this. So what you do here is you calculate the error and how that has changed from your current position and the previous position, and that is now your derivative force. And then what you do is you take all of these three components, the proportional force, the integral force, and the derivative force, and they each have a theta value that we have picked in the top, and then you multiply that with each force, and then in between them you just use the addition, as we have discussed with linear combinations. Now we have calculated the force, and then you update the position with that force. So you take the position of the drone and then you plus equals the force of the drone. So that is basically it. I think that this might have be a bit much, but what I suggest is that you go ahead and clone this, and then you go through all the functions, and then you try to mess around with these variables here and focus on understanding what's going on in the update function with this proportional force, the integral force, and the derivative force, and how they are calculated. And I think also you should rewatch the first part where I talk about use cases, with bearing this in mind, how it is applied, because it'll probably make much more sense if you think of this scenario and the use cases that I talked about. So that is that. If you have any questions, leave it in the comment section below, and don't forget to subscribe if you haven't already. And I hope you liked it, and I will see you in some other tutorial, I guess. Bye bye.